and set the standard shader as the beauty shader. As we are in ACES, I'm going to change the color space to utility raw as this is a data map, and we should have done that with the bump maps in our previous lesson. So I forgot that, but do that as well. Now connect the output of the image to the displacement input of the displacement node. The amount of displacement mapping is too much. That's why we see nothing relative in our render. Select the displacement node and decrease its scale, which is the amount of displacement mapping, in this case to something like 0.1. Obviously, we don't have enough subdivision to get enough detail. So select the Arnold parameters tag and increase the iteration to about 8. I can increase the iteration number to get more detail or decrease it to decrease the overall detail. In this case, something like 8, 9 would be enough. Now, if I wanted to preserve the cubical shape of my base geometry, I can change the subdivision type to linear. When we do that, there is something wrong with the displacement mapping. If you go to your displacement tab of the Arnold parameters tag, you have a parameter called bound padding. Padding defines how much to extend the bounding box of the object so that it can include any additional displacement coming from the displacement shader. So when the padding is set to 0, because we don't have big enough bounding box, we see this artifact in our render. By increasing the padding and extending the bounding box of our geometry, we will be able to get our displacement mapping the way it's supposed to be. Use this value sparingly, something like 10-20 centimeters of additional padding will be enough here. Now, if I get back to my shader network editor and select displacement node, here scale controls the amount of displacement. So if I go to 0.2, we are going to get a larger displacement map. Also, you can use negative values, which will invert the effect of displacement. In this case, I'm going to set it to something like 0.05. We have scalar 0 value, which is applied as a shift to the displacement amount. It defines the value of the displacement map that is considered to be 0 displacement. By default, it is set to 0, so the black values of the texture are not going to get any displacement, so 0 displacement, and everything brighter is going to be displaced to the outward direction. When set to 0.5, 50% gray will be 0 displacement map, darker values in the texture will be displaced inward, and brighter values will be displaced outward. And when set to 1, white pixels will have 0 displacement and darker values will be displaced inward. Let's set the scalar value to 0.5 for now. Also, let's select the Arnold parameters tag that is applied to our cube and see what other displacement related parameters are under the displacement tab. We have the height, which is like the scale value in our shader, and it controls the amount of displacement mapping in conjunction with the scale value. We discussed padding. We have another scalar 0 value, which works like the one in the shader. We have auto bump, and as soon as I enable it, we get more details. Auto bump puts the high frequencies of a displacement map into the bump attribute so that you do not need as many subdivision iteration values to get really high quality and high detail displacement mapping. And I suggest to have it turn on to get higher quality displacement mapping, especially with normal displacement mapping. Also, we have vector displacement mode. Let me hide my cube object and unhide this smaller plane. I'm going to create a new Arnold standard surface shader and rename it to vector displacement and assign it to the plane. Open its network editor. Now search for displacement map, add one and connect its output to the Arnold displacement port. By the way, if you don't see this port, simply click on this red corner of the main group and you can find all the available ports, including Arnold displacement map. Simply click on it to be added. Now add an image node and load this ear texture and connect it to the displacement input of the node. There is nothing particular in the render. Let me stop the IPR. I'm going to add an Arnold parameter tag to the plane. Go to the subdivision tab and change the type to Catt-Clark and increase the iteration to about 5. Now we are ready to see some displacement map, but if I run the IPR, we still get nothing. Let's get back to our network editor and see what's going on. I mentioned that the difference between normal and vector displacement is that in normal displacement, we only have two directions, up and down. So we can raise the geometry or lower it, but we can't move it in any other direction. But with vector displacement, we can actually move our geometry in different directions. Let's select the vector displacement node and change the vector space to tangent, because that's the way I generated this ear displacement texture. The order should be X, Y, Z, and reduce the scale to something like 0.3. Scale here controls the amount of displacement mapping, obviously. Also select the Arnold parameters tag and under displacement change the padding to 10-20 centimeters. Now, as you can see, we have a perfect ear geometry in our scene. Now let's discuss different parameters that we have in the vector displacement node. We have scale, which controls the amount of displacement map. Higher values yield stronger effect. We have this signed checkbox. If you have a 32 or 16-bit input map, this should be unchecked. But if you have an 8-bit input, you can check the signed option to get more info out of your map. In this case, I have a 32-bit image, so I can keep it unchecked. Then there is vector space, world, object, and tangent. So based on how you generated the displacement texture originally, you can choose your desired coordinate space. We have tangent, which is the input attribute for connecting a tangent-based vector displacement map. You can change the channel orders and flip different channels. I wouldn't be able to cover every little detail practically here. It would go on forever, but I refer you back to this tutorial on Arnold website, which explains the workflow from scratch on how to generate vector displacement maps and how to apply them. It's called rendering displacement maps from Cinema 4D. So that's about subdivision and displacement mapping in Arnold for Cinema 4D. See you in the next video.